Howdy folks, Doc here with Last Best Tool, and today I was playing around with the strength of some of the magnetic bit holders that actually I use all the time for all kinds of different jobs, and I have a handful of different types, and I've noticed that there are definitely some significant strength differences. So I set up this tester. So I've got my Vernier dual range force sensor here just attached to a block of wood, put in a vise, and then I wired in a Milwaukee bit, so I can just slide these things on and then turn it on, get the computer ready, and pull them off and actually get the force measurement. And I did this across a bunch of different bit holders and across some of the bit handles, the drivers. And I came up with, first of all, two big category differences. One is that the drivers kind of all seemed pretty close, and that was not very much power. Even this Craftsman, imagine that. Anyway, but the bit holders were really in two distinct classes, meaning there were some that had like an extra retention ring in them, and that extra retention ring held the bit significantly stronger, harder than the ones that were just purely magnetic. The weakest by far were these little sliding ones designed like for deck screws or flooring, stuff like that. These barely held on. I'll go over the numbers in a minute. Some middle ones like the Snap-on, this is designed as a bit holder without extra retention. This was one of the stronger ones of just the magnetic. But then some of the others that had some sort of extra retention in them, really like significantly stronger, like this Milwaukee. So once it's on, which you'll feel that they are obviously not quite the same. They don't just pop on. You have to force them on. This thing is way stronger, but you also see there's play there. That's when it breaks free of the magnet. And then it goes into that secondary retention of the ring, which actually holds the bit on quite a bit more securely. But I think they call them magnetic bit holders because there technically is a magnet, and it isn't an active retention like something like this, where if I slid this on, this is not going to come off without breaking something. But these will pop off. So what did I discover? In my numbers, as I was doing the tests, I came up with a couple of real significant winners, and in this case they were these two. This is that Makita that without the cover on it that I did an unboxing of not too long ago, that's supposed to be twice as strong. What I noticed here is it's once you've got something in, there's a lot of play here. See that? And so it really almost doesn't have any magnetic feel, which is odd. But it really grabs the bit with some sort of a retention mechanism up here. So I don't know why they even call it magnetic. I don't notice that. And then if I drop a regular bit into it, you know, I still have that little bit of play. So if you drop it into a magnetic one, there's no play. You know, I'm not holding on to this. So there seems to be some disagreement as to exactly what magnetic means. This Snap-on one does have a magnet, holds it really tight, but it also has a little bit of, or not a little, a lot of active or of a passive retention around the end there, because I can pull it free of the magnet, and then it goes to that secondary retention. Anyway, get back to some numbers here. So I did this in basically pounds of force to remove it, and the Snap-on was about 4.5 pounds, which was a lot in this kind of a test. However, this Makita, which was, remember in the unboxing, was rated like at twice as strong. This thing was 7.3. So 4.5 for Snap-on, which was number 2. This was 7.3, number one. A few others more kind of notable, some of the Milwaukees. These were around 3, 3.5, which was interesting. They're pretty solid. They do seem, I don't know if it's an alignment issue or what. Sometimes they're really hard, to get into the position. So I don't know if it's quality control or what. But once they're in, they're nice and solid. But again, I notice a little bit of magnet. That's what pulls it back on. But this secondary part here where I've broken free from the magnet is pretty strong as well. In fact, that's a significant part of the retention. So there are definitely two approaches to this. When it came down to the handles, one thing I noticed is these are both Max. This part looks about the same on these two Max. However, there was a difference. This one came in a kind of a package. It doesn't seem to be made quite as well. The finish work, this has got more detail to it. It's also the one that I like better because it's a little bit smaller. This one matches this bit driver that came in a set. And anyway, I don't think that they did everything as best as they could with this. But there was a difference. This smaller one was actually stronger than the slightly larger one. And it wasn't by a lot, but it was definitely noticeable. In fact, it was 1.6 pounds for the larger, kind of what I'm going to call the cheaper one, the package set one, and 2.6 pounds for the one that you would buy individually, off a truck. So there was a difference. Oddly, Milwaukee scored quite well. Milwaukee's got 2 entries in my test, the stubby and this larger one. And the 2 here, the larger was 2.6, the smaller was 2.5 pounds, which is pretty dang good, and kind of made a mess of these 2 old Snap-ons. They don't make these anymore. They're just purely magnetic. There's nothing fancy going on in here. But this Snap-on without the bit pocket in the back came out at about 1 pound, which is pretty low. I didn't notice that. It always seemed to really hold it in pretty snug, but that's about it. And then the one that had the bit end was 1.1 pounds. Slightly newer, I guess, maybe. However, this Snap-on ratchet one came in at 1.8. So that's almost a full pound less. This was 2.6. So this definitely has much more retention. However, this comes with these longer bits. If I have one out like this, so it really needs to have a probably a little bit stronger retention, simply because it's got a more massive bit. It does work fine with the smaller ones, but you can see it drops in quite a ways, to the point I'm probably going to need to grab it out with pliers. But anyway, it's designed for a heavier bit, so probably heavier magnet. I assume there's a sweet spot somewhere between too much and too little. Anyway, the Craftsman was 1.75, which was actually more than the Snap-on, than the old Snap-ons. That kind of surprised me. And then I did this little tiny Wera that I got. This thing was 2.1, which is highly respectable. That was, remember that the Snap-on here, this Snap-on ratchet, was 1.8. So this is less than the Milwaukee, but more than the Snap-on. So highly respectable there. Anyway, it was kind of fun testing these out and putting some numbers on it. It's not a pure real-world test, but it definitely gives me a way to compare these, so it isn't just the feel of it. I don't know if I mentioned this Mac ratchet. This was 3.4, which is actually quite good, which kind of surprised me. It came in the same set, as this one. So that scored well. Anyway, I'll probably be doing more with this as I play around with the sensors and look for different ways to measure these. But for now, Snap-on in for the win on bit holders, unless you want to go to some sort of other clicky retention. Then the Makita wins, and then Milwaukee seems to be the hands-down winner of these bit drivers, with Max second. So, with that, Doc out.